Welcome to this explainer. Today, we are taking a trip to the darkest, most extreme corners of our planet to explore a moment that literally shattered everything we thought we knew about life on Earth. I'm talking about a legendary deep-sea expedition in 1977. A surface ship called the RV Noor deployed a tiny, cramped submersible down into the pitch-black ocean, and, well, they ended up rewriting the scientific textbooks forever. Okay, let's dive right into this. The year is 1977. Up until this exact moment, the global scientific community held a very specific, incredibly rigid view of how our planet functioned. The absolute cornerstone of biology was that all life, everywhere, was ultimately tethered to the sun, right? No sunlight meant no photosynthesis, and no photosynthesis meant no life, period. But a single expedition into the abyss asked a massive question that we're going to answer today. How could one anomalous, completely accidental discovery totally flip our understanding of biology, geology, and even astrobiology on its head? For decades, oceanography was locked into this unyielding dogma closely tied to something called the azoic hypothesis. Basically, scientists firmly believed that past a certain depth, the ocean floor was just this desolate, frozen wasteland. A total biological desert. It was assumed that the only way the incredibly sparse life down there survived at all was by scavenging on what they call marine snow. It's essentially a bleak, slow-motion rain of detritus, dead plankton, and organic scraps just slowly drifting down from the sunlit surface, miles above. The deep ocean was thought to be a geological graveyard. But the reality they stumbled upon in 1977 was the exact opposite. Hidden in the crushing, pitch-black depths, they found a vibrant, totally alien ecosystem thriving entirely independent of the surface world. Section 1. The 1977 discovery, the Alvin submersible. So, picture this. The stage is the Galapagos Rift, which is this area of active tectonic plate spreading in the eastern Pacific. You've got two geologists, Jack Corliss and John Edmund, squeezed inside the claustrophobic titanium sphere of the Alvin submersible. They are descending nearly 2.5 kilometers beneath the surface. Now, keep in mind, they were on a strictly geological mapping mission. They fully expected to find absolutely nothing more than barren, boring basalt rock and incredibly cold, near-freezing, stagnant water. But as they approached the seafloor, something completely baffling happened. The scientists watched their instruments with just growing bewilderment. The water temperature sensor, which absolutely should have been hovering around a frigid 2 degrees Celsius at those crushing depths, began to climb. And I mean climb rapidly. It was a totally impossible reading in a place defined by cold and darkness. 400 degrees Celsius. That is 750 degrees Fahrenheit. Now, what's really interesting about this is that instead of a desolate crust, they looked out and saw these towering, chimney-like structures rising directly out of the seafloor. And they were violently venting plumes of this dark, mineral-rich liquid that billowed exactly like smoke from an industrial factory. They had just discovered what we now call hydrothermal vents, specifically the black smokers. Now, you might be wondering, how on earth can water reach 400 degrees Celsius without instantly boiling away? Well, the answer lies in the immense hydrostatic pressure. At 2,500 meters deep, the pressure is about 250 times greater than it is at the surface. That immense weight actually compresses the superheated water, preventing it from turning into steam and trapping it in this dense, supercritical liquid state. Section 2. Anatomy of a black smoker, and how that smoke actually forms. There is a chaotic, highly dynamic, 3-step mechanical process driving these vents. It acts almost like a massive sub-seafloor plumbing system, and this brilliantly illustrates exactly how it works. Step 1. Freezing, cold, heavy seawater seeps deep down into the porous cracks and fissures of the ocean's newly formed crust. Step 2. As this water travels miles downward, it gets perilously close to the magma chambers. It gets superheated to that blistering 400-degree mark, becomes highly acidic, and basically acts like a hyper-efficient chemical sponge. It leaches massive amounts of minerals, things like sulfur, iron, copper, and zinc, straight out of the surrounding basaltic rock. Finally, step 3. This searing, buoyant, metal-rich fluid shoots back up and violently collides with the near-freezing, highly oxygenated deep ocean water. That extreme and sudden drop in both temperature and pH causes those dissolved metal sulfides to instantly precipitate out of the fluid. They literally solidify into tiny black particles right there in the water, creating that swirling, billowing smoke that continuously builds those towering chimneys higher and higher over time. Section 3. The impossible ecosystem, or life without the sun. Okay, so the geology was undeniably groundbreaking, but the most profound twist of this entire expedition was what they found living directly on top of these incredibly hostile structures. Before this moment, as we discussed, life meant photosynthesis. But here, miles beneath the reach of any photon of sunlight, was chemosynthesis. Down in the pitch black, specialized bacteria were utilizing the deep-sea chemicals for energy. What makes this a massive biological marvel is that the fluid spewing from those chimneys is absolutely loaded with hydrogen sulfide. That's a compound that is highly toxic, basically the equivalent of cyanide for most life on Earth. Yet these amazing bacteria had actually evolved to oxidize this lethal compound, using the energy released from that chemical reaction to fix carbon dioxide into organic carbon. They were literally building the base of a bustling food web using poison instead of sunlight. It's just wild. And what a fascinating, totally alien food web it is. Supported entirely by these chemosynthetic bacteria, the scientists found dense, vibrant communities of completely bizarre creatures, thriving in high-pressure, highly toxic, scorching hot environments. Take the giant tube worms, formerly known as Riftia pachypila. These creatures can grow up to 8 feet long, and the absolute craziest thing about them, they don't even have a mouth, a stomach, or a digestive tract. No way to eat. Instead, they house massive colonies of those chemosynthetic bacteria inside a specialized organ called a trophosome. The worms use bright red hemoglobin-rich plumes to absorb hydrogen sulfide and oxygen from the water, delivering it directly to the bacteria living inside them. In return, the bacteria produce all the food the worm needs to survive. It is a perfect, deeply strange symbiosis. And crawling among them are these creepy albino crabs and eerie, translucent fish, entirely cut off from the surface world, yet flourishing. Section 4. The Cosmic Ripple Effect and Rewriting the Rules. The sheer scale of this find simply couldn't be contained to just marine biology. It rippled outward, fundamentally rewriting the rules across 3 massive scientific disciplines. In geology, it proved once and for all that the ocean floor isn't just some static, boring slab of rock. The hydrothermal circulation at these vents acts as a planetary thermostat, actively regulating the chemical composition of the global ocean over millions of years. In biology, it radically expanded the tree of life, formally introducing us to extremophiles, organisms that don't just survive, but actually prefer and thrive in extreme heat and toxic chemistry. And perhaps most mind-bending of all is the impact on astrobiology. So, the crucial point here is that it completely shifted our search for extraterrestrial life. If life could thrive in the dark, acidic, geothermally heated depths of Earth's ocean, well, it could theoretically exist in the subsurface, tidal-heated oceans of distant moons, like Jupiter's Europa or Saturn's Enceladus. We suddenly realized that ocean worlds might actually be the most common habitat for life in the entire universe. To really put this into perspective, scientists at the time described this discovery as the biological equivalent of finding a brand new continent right here on Earth. It wasn't just a fun new animal fact. It fundamentally altered our understanding of the origins of life itself. A lot of researchers now believe that life on early Earth might not have started in some warm surface pond struck by lightning, but rather deep underwater. Down there, it would have been sheltered from asteroid impacts and deadly UV radiation, clinging to the thermal energy events just like these. It proved that the final frontiers of our own world still hold massive, world-changing secrets just waiting to be decoded. Which leads us to our final, lingering thought for this explainer. If the deepest, darkest, most extreme parts of our own world can hide such vibrant, seemingly impossible secrets right under our noses until 1977, what exactly is waiting for us out there? Hidden in the dark, subsurface oceans of moons like Europa? The rules of life are far wider and far stranger than we ever imagined. Thanks for joining me on this deep dive into the abyss, and as always, keep questioning what you think you know.